All right, so we're back and we've got another question, and the question is asking us to find the primary trig ratios of 7 pi by 6. We should decode a few things here. Primary trig ratios are talking about sines, cosine, and tangent. And when you're asking to find the trig ratios of an angle, you're going to end up finding one of those exact value ratios. So our answer should contain probably root 3's and 2's and 1's. Now, the first thing I do when I have to find a primary trig value of a particular angle or a specific trig ratio of a particular angle is I draw the angle. So I'm going to go ahead and do what I did before and draw myself a unit circle. There's my unit circle. I could label X, Y, and all of that, but I don't really need to, I find. Especially since this is just rough work. You don't need to actually show this, because a lot of people just have those three things memorized for 7 pi by 6. Now, where is 7 pi by 6? Well, this is 0, but it's also 2 pi, which means it's also 12 pi by 6. It's useful to kind of know that this is like a full rotation is double the denominator. So that means if this number is larger than the denominator, then your angle has to be in your bottom two quadrants. If this number is smaller than your denominator, then it's got to be in your top two quadrants. So 7 pi by 6 is one of the ones that is right here. Now, not the best drawing, I'll admit it. Didn't use a ruler or anything like that. But I do have a little trick. If it ends in 6, it's close to x. If it ends in 3, it's close to y. So if I'm talking about something multiples of pi by 3, then those are the angles that are closer to the y's. If it's something to the angle pi by 6, those are the ones that are closer to the x-axis. And if it's halfway in between, well, that'll be when it's a 4, like we saw in our previous video. So now once I've drawn the angle, I'm going to go ahead and draw the sine. I'll use different colors for the sine. So my sine is right there, and I'll just correct my axes just because I feel like that was a really bad axis. Sorry, my daughter stole my ruler. So there's my sine of 7 pi by 6. So this question is saying find the length of that if this length here is 1. Now I'm also going to draw in my cosine. So my cosine would be right there. And if I wanted to draw in my tangent, I'd have to get really fun, because I think my tangent is right there. And you'd have to visualize that circle coming up and then that line being tangent at just that one point. But fortunately, it's a heck of a lot easier because I don't need to do all this drawing and circling and all that sort of stuff. I'm just going to jump to it pretty quickly here. So draw, 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 sine, and I know what type of triangle this is. This is my 1, 2, root 3 triangle. I know it's a root 3 because the denominator has a number that's divisible in 3. If it's 5 pi by 3, then I'm using the root 3 triangle. If it's 7 pi by 4, then I'm using the root 2 triangle. If it's 7 pi by 6, I'm using the root 3 triangle. So I know the longest side here is 2. I know that the shortest side here is 1, which means that this has to be root 3. Great. Next, if you recall the cast rule from before, you can use that, or you can use the fact that this 1 is down from the x-axis, so it's got to be negative, and this 3 is back from the y-axis, so it's got to be negative as well too. Now let's go ahead and list our sine. So our sine of 7 pi by 6 is equal to the opposite over the hypotenuse. Our cosine of 7 pi by 6 is equal to the adjacent over the hypotenuse. Our tangent of 7 pi by 6 is equal to the opposite over the adjacent. And we should definitely be reducing that by eliminating those negative signs, so 1 over root 3. Now, this is also a pretty good time for me to show you why I use the 1, 2, root 3 triangle rather than the 1 over 2 and root 3 over 2 triangle. So why did I do that scale up in the previous video? The reason why I did that scale up is because what if it wasn't just find the primary trig values, but find all of the trig ratios? Well, that means, oh geez, I'm going to have to go and find the Cotangent. Okay, so to find the cotangent, I've got to do root 3 over 2 divided by 1 over 2. Okay, now to find the secant, I've got to do root 3 over 2 divided by 1. Okay, that's not as bad. But it's a lot easier if you just have these values here, because now when we know, okay, I got to go find my cosecant. Well, the cosecant of 7 pi by 6 is a reciprocal function that's related to my sine. So I know that it deals with these two values just in the opposite order or reciprocal order. So rather than being negative 1 over 2, it's 2 over negative 1 or negative 2. To find my secant, I know that that's a reciprocal function of my cosine. So I know it deals with those two just in my opposite order. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Again, it's negative. And then lastly, to find my cotangent, I know my cotangent is just the reciprocal of my tangent. So it's going to be, again, the opposite and the adjacent, but in the opposite order. It'll be root 3 over 1. And I'm going to just leave it as positive this time because I recognize those are both negative signs. I also don't need to write that it's divided by 1 because why would you? But that's a sufficient answer. So this is using primary trig ratios and a unit circle for another value.